Hi kids, in a previous video we solved till sum number 17 of exercise 15.1 circle from class 10. Let us continue from sum number 18, Aggarwal. In this figure, chord AB and CD intersect at E. Number 1, prove that triangle ADE and CBE are similar. Very easy. First I'll do this part. Look over here. This angle and this angle will be equal. Angle of the same segment. Look, CBA, CDA. Angle CBA is equal to CDA. Why? Same segment, isn't it? Now look. Instead of CBA, can I write CBE? Same thing. Instead of CDA, can I write EDA? Means the same thing. Now look at triangle CBE, triangle CBE and triangle ADE. ADE. If you look at these two triangles, angle CBE angle CBE is equal to ADE. ADE, already done, proved, isn't it? Next, this angle and this angle will be equal, vertically opposite angle. Angle CEB is equal to AED, vertically opposite angle, which means by angle property we can say that triangle CBE is similar to triangle C corresponds to A, B corresponds to D, ADE. Done. This is angle property. Now once you prove that these two triangles are similar, then we know the corresponding sides are proportional, which means CB by AD is equal to BE by DE is equal to CE by AE, isn't it? Look at the second part. This will be used in the second part. Given DC is 12 centimeter, DE is 4 centimeter. So just look carefully. DC is 12, DE is 4. So what is CE? CE is definitely 12 minus 4, that's 8 centimeter. AE is given as 16 centimeter. They've asked for BE. They've asked for BE in the second part. Look at this. Okay. Take these two. Okay. BE, we don't know. DE is 4. CE is 8. AE is 16. So that's BE will be 2 centimeter. Done. Pretty easy. Used angle in the same segment over here. Vertically opposite angle. So these two triangles are similar. Once they are similar, we know the corresponding sides are proportional to each other. With that, we can get the second part. Clear? Now let us look at the next sum. Now look at this sum. Sum number 18 part B. In the figure AB and CD are two intersecting chord of a circle. Name two triangles which are similar. We'll see that. Hence calculate CP. Suppose we take this as X. CP as X centimeter. Given that AP is 6, PB is 4 and CD is 14. So if CD is 14, I have taken CP as X. So can I take PD as 14 minus X? Look over here. This is 14 minus X. Okay. And they're given PC is greater than PD. Quite evident from the diagram, but still. Okay. Why they have given? We'll see that. Now, first of all, we need to show that which two triangles, we need to find which two triangles are similar. Look at this triangle and this triangle. I'm talking about triangle APD and CPB. First of all, look, this angle. Okay, I'm talking about BAD. angle BAD is equal to BCD. This angle, same segment, isn't it? Look, BD is the segment. And this angle, look over here, CDA is equal to CBA angle in same segment. They have to be equal, isn't it? Now, angle BAD is nothing but PAD. So, angle PAD is equal to PCB. We just got over here. And angle ADP is equal to BCP. We just proved it, okay, over here, which means I can say triangle APD is similar to triangle CPB by angle property. Done. Very easy. You could have done vertically opposite angle also. Okay. Now, once you got this, the first part, we know if two triangles are similar, the corresponding sides are proportional, which means can I write AP by CP equals to PD by PB equals to AD by CB. Okay, now look, CP. Take the first two. AP by CP is equal to PD by PB. Now AP is how much? AP is known to us. Let us see. They have told us AP is 6. Okay. CP we are supposed to find. Okay. This is 6. CP. PD I have taken as 14 minus X. Okay. And PB I have taken as 4. Just a minute. CP I have taken as X. So instead of this, I'll put X. Now I need to find the value of X over here. So this is 24 equals to 14x minus x square. X square minus 14x plus 24 equals to 0. That's a quadratic equation. Solve it. X square minus 12x minus 2x plus 24 equals to 0. Which means x minus 12 minus 2, x minus 12 equals to 0, which means x minus 12. I'm just factorizing by middle term, which means either x equals to 12 or 2, which means either CP equals to 12 centimeter or 2 centimeter. Now, 12 centimeter is correct. How come? Because if we take CP as 2 centimeter, then PD becomes greater than CP, which violates this, which means your CP is 12 centimeter. Pretty easy. Just prove that they are similar and use this property. Done. Now let us look at the next sum. Now let us see sum number 19. In the figure, AE and BC intersect each other at the point D. Angle CDE is 90 degree. AB, so when we join this, AB is 5 centimeter, BD is 4 centimeter, and CD is 9 centimeter. Find DE. Very easy. Just join CE first. Okay. Okay, in this triangle first, look over here. This is 90 degree, no doubt. In triangle ADB, just look carefully. AD square by Pythagoras theorem plus DB square is equal to AB square by Pythagoras theorem. You need to write this, okay? Which theorem you are using. So AD square we don't know. DB is 4 square is equal to 5 square. So AD square is 25 minus 16, that's 9. So AD will be plus minus 3, so we'll take 3 centimeter. This is 3 centimeter. Done. Now what I'll do, I'll prove that these two triangles are similar and use the property. My work will be done. Now first of all, look carefully. This angle, I'm talking about angle EAB. Angle EAB and ECB. ECB will be same. Why? Same segment, isn't it? Same segment. Just look carefully. Now look at those two triangles. I'm talking about triangle ADB and triangle CDE. First of all, angle DAB is equal to DCE by this, isn't it? Already proved. Then if you look, these two angles are equal, vertically opposite angle, 90 degree each. Angle ADB is equal to CDE, vertically opposite angle, which means two angles are equal, they are similar, which simply implies that triangle ADB is similar to triangle CDE. Now, if they are similar, their corresponding sides are proportional, which means can I write AD by CD, DB by DE is equal to AB by CE. Now they have asked for DE, so we'll take this. They've given BD. What they've given? See, AD they have given as 3, CD they have given as 9, DB they have given as 4, DE they have asked. Just taking the first two, isn't it? So DE will be 4 multiplied by 9 divided by 3, that's 12 centimeter, which means DE is how much? 12 centimeter. So we just needed to prove that those two triangles are similar. Once you prove they're similar, then use the property that in similar triangles, the corresponding sides are proportional to each other. Done? Clear? Now let us look at the next sum. Now look at triangle part A. I think this is the easiest one. In the figure, PR is the diameter of the circle, PQ is 7 centimeter, QR is 6 centimeter, RS is 2 centimeter. Find the perimeter of the cyclic quadrilateral PQRS, which means we need PS. If we get PS, our work is done. Now just look carefully. This angle and this angle has to be 90 degree each. Why? Because PQR, PR is the diameter, so angle of the semicircle is 90. Similarly, PSR, angle PQR is equal to PSR equals to 90 degree each. Angle at semicircle, angle at semicircle, isn't it? Ekdam easy. Now look carefully. I'll use Pythagoras theorem in PQR. In triangle PQR, if you take, PR is the hypotenuse. How? Opposite to 90 degree. So PR square is equal to QP square plus QR square, which means PR square is equal to 7 square plus 6 square, that's 49 plus 36, that's 85, isn't it? Leave it like this. What I'll do, look at triangle PRS. Triangle PRS. Again, PR square is equal to PS square plus RS square. According to Pythagoras theorem, you need to write, okay? Pythagoras theorem, isn't it? Mention over here when you're using the theorem. Pythagoras theorem. So PR square is what? 85. PS square, we don't know actually. RS square, which means 2 square. So 85 equals to PS square plus 4, which means PS square equals to 81. So PS will be plus minus 9, so we'll take 9 centimeter. Positive because length cannot be negative. So this is 9 centimeter. So the perimeter, if you look carefully, will be 7 plus 6 plus 2 plus 9. That's 13, 15. That's 24 centimeter. Clear? Very easy, okay? Just use Pythagoras theorem and this angle at semicircle. Done. Now let us look at the next sum. Now look at this sum. 20 part B. In the figure, the diagonal of the cyclic quadrilateral A, B, C, D intersect at P, and the area of triangle APB is given as 24 centimeter square. If AB is 8 centimeter and CD is 5 centimeter, calculate the area of triangle DPC. Very easy. Look at these two triangles. Just prove that they are similar, our work is done. First of all, if you look, this angle and this angle will be equal. In triangle APB and triangle DPC, if you look, angle APB is equal to DPC. Why? Vertically opposite angle. Okay, now look carefully. Angle ABD, which means this angle ABD, will be equal to ACD, this angle ACD, same segment, isn't it? Look carefully, the segment is AD, same segment. Angle ABD can be written as ABP and ACD can be written as PCD. So we can say that angle ABP is equal to PCD, same segment, isn't it? Now, once two angles are equal, we know that we can say it simply implies that triangle APB is similar to triangle A corresponds to D, P corresponds to PC, angle property. Now, if these two triangles are similar, we know that area of triangle APB by area of triangle DPC will be equal to, see, AP square by DP square will be equal to PB square by PC square will be equal to AB square by DC square. Isn't it? We have done this theorem. Done. Now take the first one, and what was given to us? This one. First one or the last one? Area of triangle APB is 24. So 24. Area of triangle DPC, suppose X. AB square is 8 square. 8 square is 64. DC square is 5 square. That's 25. So X will be what? 24 multiplied by 25 by 64. Am I correct? 8 3 times, 8 times. That's 75 by 8. That's 9 3 by 8. Am I clear? So area of triangle DPC will be 9 whole 3 by 8 centimeter square. Very easy. Just prove that they are similar and use this property. Done. Now let us look at the next sum. Now look at 21 part A. In the figure, QPX is the bisector of angle YXZ, which means this angle and this angle will be equal of triangle XYZ. Prove that XY is to XQ is equal to XP is to XZ. Just look at triangle XYQ and triangle XPZ. We'll try to prove them similar. Our work will be done. First of all, if you look, this angle and this angle are equal, same segment. Look, YQX is equal to YZX, same segment, isn't it? So YQX will be, instead of YZX, can I write PZX? I can. Now look carefully. In these two triangles, first of all, angle YXQ, which means this angle and this angle PXZ are equal. Why? Because QX bisects angle X, isn't it? They have given already. Next, we got this angle YQX is equal to angle PZX. We already proved. which means by these two we can say that triangle XYQ is similar to triangle XPZ, and if they're similar, the corresponding sides are proportional, which means XY, let me see this one, XY by XP is equal to YQ by PZ is equal to XQ by XZ, isn't it? So now take the first one and the last one. So XY by XP is equal to XQ by XZ, which we can write as XY by XQ is equal to XP by XZ, isn't it? Which is nothing but XY is to XQ is equal to XP is to XZ. Proved. Very easy. Just we need to prove that these two triangles are similar. Okay, we used angle of the same segment property. Done. Now let us look at the next sum. Now look at this sum, 21 part B. Very easy. In the figure, chord AB and DC of a circle meet at P. Prove that angle PAD, this angle, is equal to PCB, this angle. Okay, and then PA multiplied by PB equals to PC multiplied by PD. First of all, the first part. If you look at angle BAD, angle BAD and BCD, the segment is same, so they'll be same. Suppose Y, same segment, isn't it? Now just look over here. So this is Y and this is Y. Now look, angle PAD will be 180 minus Y, linear pair. These two angles add to give 180. It's a straight line. And angle PCB is again 180 minus Y, linear pair, which clearly says that angle PAD is equal to angle PCB. Done. Clear? Now look at the second part. In the second part, what I'll do, look at triangle PCB and triangle PAD. I'll try to prove they are similar. First of all, this angle and this angle are equal. Why? Same segment, see, ABC. Angle ABC is equal to angle ADC, isn't it? Same segment. Now angle ABC, can I write as PBC? Same thing. And angle ADC, can I write as angle ADP? Same thing. So first of all, in these two triangles, look over here. The first thing, angle P is common. So CPB is equal to APD. That's common angle. And this we just got, angle PBC is equal to ADP. Just proved, which means triangle PCB is similar to triangle P, and C corresponds to PAD, isn't it? Now, if these two triangles are similar, the corresponding sides are proportional, which means PC by PA is equal to CB by AD is equal to PB by PD, isn't it? Take these two, the first and the last one. So PC by PA is equal to PB by PD. So we can say PA multiplied by PB will be equal to PC multiplied by PD. That's proved. Very easy. We just needed to prove that these two triangles were similar. Angle property. So this was the last sum from the text. Keep it till here in this video. In the next video, we'll look at the other theorems on circles of class 10. This was exercise 15.1. Till then, take care.